now that we've studied somewhat about polar coordinates and polar graphs, we are now going to look at polar coordinates and graphs and calculus. At the end of this lesson, you'll be able to find the derivative of a graph represented in polar form. All right, we've got an equation that we're going to work with. Before we actually start using this equation, I'm just going to show you where it came from, because if you did not remember this formula or just did not want to memorize it, you can easily derive it. So I'd like to just show you where that came from. So we're going to have x equals r cosine theta and y equals r sine theta. Those were just when we converted from polar coordinates to rectangular coordinates. And then since this says to find dy dx, we're going to be finding the derivative of the y divided by the derivative of the x. Well, to get the derivative of the y, you'll notice since we have two variables, we're going to have to use the product rule. So this would be f and g, and then f prime would be just 1, and g prime would be cosine theta. Well, actually, it would not be 1, it would be r prime. The derivative of r is r prime, since r is a variable and we're not with respect to itself. All right, and so then the derivative would be y prime would equal f prime g, so r prime sine theta, plus, and then f g prime, so r cosine theta. And notice that's exactly what this says in this formula. And then to get the other part, we do same thing, f and g. F prime would be r prime, and g prime would be negative sine theta. So if we wanted to find x prime, that would be f prime times g, so r prime cosine theta, and then f g prime would be negative r sine theta, which is, notice, exactly, it's just in a different order, but it's exactly what we have on the bottom. So again, if you had trouble memorizing that, it's right there for you. All right, so we would like to find dy dx for the polar curve r equals 4 times the quantity 1 plus cosine theta. One thing that I'm going to do here real quick is just actually distribute that out. So r actually equals 4 plus 4 cosine theta. I think we might find that easier to work with. All right, so what we're going to do, we're going to get dy dx. That will equal r, which is 4 plus 4 cosine theta times cosine theta plus r prime. Well, r prime will be, the derivative of 4 is nothing. The derivative of 4 cosine theta will be negative 4 sine theta. So it'll be r prime. So negative 4 sine theta times sine theta. And then over the dx would be negative r, so negative r will be 4 plus 4 cosine theta again, times the sine of theta, plus r prime, negative 4 sine theta, times cosine theta. All right, and then from here I'm just going to simplify it a little bit. I'm going to distribute my cosine to both parts inside the parentheses. I'm going to get 4 cosine theta plus 4 cosine squared theta. And then this part will give me minus 4 sine squared theta. And then in the denominator, I will get negative 4 sine theta minus 4 sine theta cosine theta. And then I will have minus 4 sine theta cosine theta again. Okay, so distributing things, I guess we could factor out a 4 from everything. I guess that would make it a little bit easier. So I'm just going to divide it out of every single term. I think that will make it a little bit easier. So I will have cosine theta, so dy dx, will equal cosine theta plus cosine squared theta minus sine squared theta all over negative sine theta. And then if I combine these two, then after I divided out the 4, I'll have minus 2 sine theta cosine theta. So that would be the derivative. Doesn't that look fun? All right, next example, it says for the example above, find the points of horizontal and vertical tangents. And I'm actually going to change this problem to make it a little bit shorter. We are just going to do of vertical tangency. All right, so what we need to do is first of all start with that derivative. If you recall, it was dy dx equals, let's see, it was 4, that was just cosine theta plus cosine squared theta minus sine squared theta, and it was all over negative sine theta minus 2 sine theta cosine theta. All right, so if we want vertical tangency, we are looking for where the slope would be undefined, and that would be when the denominator equals 0. So I'm going to take that denominator and set it equal to 0. Okay, and when I do that, I notice that I could factor out a negative, and I could also factor out a sine. So if I factor out the negative sine theta, I'll have 1 plus 2 cosine theta equal to 0 left. Now, since since it's factored, I can use the zero product property. So I can set each part equal to 0. So I can set negative sine theta equal to 0, and then 1 plus 2 cosine theta equal to 0. And when I do that, if I divided out my negative, I'll still have sine of theta equals 0, and then I'd be thinking, where does the sine equal 0? And that would be at 0 and pi. And we'll just assume that this is from 0 to 2 pi just to simplify matters a little bit. And since it says to find points, usually points are represented by x and y, so that's what we're looking for. So since we found our theta values, we know that x is equal to our cosine theta and y is equal to our sine theta. And we also know, we're going to have to do a little side trip here, because we know from the original problem that it said that r was equal to 4 times the quantity 1 plus cosine theta. So I'm actually going to have to find r before I can plug it into this equation. So if I plugged in my theta, I'm going to have r is equal to, well, actually I'll just put it right in here. I'm going to have 4 times 1 plus cosine 0 times cosine 0. And when I do that, the cosine of 0 is 1 in each case, so I'm going to get 4 times 2 times 1, which is 8. So my x value will be 8, and then doing the same thing for this one, 4 times 1 plus cosine pi times cosine pi. Okay, in this case, the cosine of pi is negative 1. Well, all right, wait. We're good here. This one's sine. This was cosine. And this was sine. Okay, we know that sine of pi is equal to 0, and cosine of pi was equal to negative 1, but actually just gives us 0. So y is equal to 0. So the one point of vertical tangency would be at 8, 0. All right, to get the other point, I'm going to come over here so I have more room. 1 plus 2 cosine theta equals 0. We'll subtract 1 for both sides, so we'll get 2 cosine theta equals negative 1. Then dividing both sides by 2, we'll get cosine theta is equal to negative 1/2. And then I need to think of, where does the cosine, first of all, equal 1/2? And let me get out my hand here. I want the upper values to just be 1, which would just be my thumb. So if I tuck that in, that's going to be at pi over 3. But now I just need to figure out which pi over 3 am I talking about. And if we want the cosine to be negative, the x values are negative over here and over here. So that would be 2/3 pi and 4/3 pi. Okay, so we found that. So now again, we have to do our x and our y. So we're going to we'll have x equals r cosine theta. So 4 times 1 plus cosine 2 pi over 3 times cosine 2 pi over 3. And when I simplify that, we do know that cosine of 2 pi over 3 is negative 1/2. And we got negative 1/2 here. So I will have 4 times 1 plus negative 1/2 would be 1/2. And then times negative 1/2. And that will give me, I believe, negative 1. And then y will equal r, which again was 4 times 1 plus cosine of 4/3 pi times, in this case that will be sine of 4/3 pi. So again, cosine of 4/3 pi we know is negative 1/2. So I'll get 4 times 1/2 times the sine of 4/3 pi would be down here, so I know it's going to be negative, and the sine of 4/3 pi would be the square root of 3 over 2. So once again, the 4 is going to cancel with the 2, so I'll be left with negative square root of 3. So another point of vertical tangency would be negative 1, negative square root of 3, if I did that correctly. So hopefully now you can take the derivative of a function given in polar form.